Welcome back, detectives. This is part 2 of a case 5, clue 4. So now what we're going to do is we're going to talk about reflections of exponential functions. But before we do that, let's just quickly review what we did in our previous part. So what we did was we reflected a linear function. We had 2x plus 1 and we reflected it. It's this blue one here. We reflected it first over the x-axis, and when we reflected it over the x-axis, every point flipped to the other side of the x-axis. So if it was above the x-axis, it now went below the x-axis. And what we got was this red line, okay? And what we found is that reflection over the x-axis in essence takes the negative values of, or the opposite values of the opposite of the y values. So for every x, the x stayed the same, but the y became its opposite. So if it was a negative 1y, the reflection was a positive 1y. If it was a positive 1 for y, then the reflection was a negative 1 for y, and so on. The other thing that we noticed is that because this was taking the opposite of the y values, and the y value is represented by the f of x, we were basically taking the negative of f of x, or the opposite of f of x. Now, when we took that same function, so let me go back to the x-axis one. So that meant then that both the slope of the new line, the reflected line, and the x and the y-axis ended up becoming the opposite of the original. So the original was 2x plus 1, and the reflected line over the x-axis was negative 2. So the positive 2 became a negative 2 for the slope, and negative 2x minus 1, and the y-intercept, which used to be 1, was now negative 1. So everything in that negative carried across the entire function. So it was a negative f of x. Okay, now back to over the y-axis. When we went over the y-axis, what we ended up doing was we noticed that every point that was on the right-hand side of the y-axis flipped over to the left-hand side, and every point that was on the left-hand side flipped over to the right-hand side. And so that meant then that our y values stayed the same, but our x values changed. So if we had a negative 1 for x on the first line, then when we reflected it, it became a positive 1. When there was a 0, the reflection just stayed the same because there was no opposite of 0. It's sort of like the pivot point. And then on the when it was a 1, when x was a 1, it became a negative 1 on the reflected line. And so as we looked at this, we also saw that that our actual equations of our lines changed, but the only thing that changed from the 2x plus 1 was the slope. The slope became a negative 2. So the actual value of the x, because the value of the x became the opposite, the slope was impacted, but the y value, which was the y-intercept, wasn't impacted, and so the y-intercept stayed the same. So when we are reflecting linear functions that are over the y-axis, instead of saying it's the negative of f of x, it's actually f of a negative x, meaning that the only thing that's changing is the x value. All right, so that's our quick little review. Now let's see what happens. Oh, and then, well, we talked about the coordinate notation, that xy becomes x negative y for the reflection over the x-axis, and xy becomes negative xy over the y-axis. You really have to see it to understand why it's that way. All right. Now let's go ahead and talk about reflections of exponential functions. Um, let's start with our standard f of x equals 2 to the x power. And the main reason I picked that is because it's the easiest one to graph. So let's go ahead and put some points in. Let's start with, let's just do -1 f. When f of x is -1, then when x is -1, then y is 1/2. So I'm going to actually pause it and graph this. You go ahead and graph it as well if you can remember, figuring out what when x is -1, when x is 0, when x is 1, when x is 2, we'll try x is 3. All right, see if you can figure those all out. Okay, so I went ahead and plotted those 5 points, and I had when x is -1, y is 1/2, when x is 0, y is 1, when x is 1, y is 2, when x is 2, y is 4, when x is 3, y is 8. And hopefully you've done the same thing. Now let's do a reflection over the x-axis, and remember that the x-axis is right here. And we want to take each point and reflect it, okay? Just make a little flip over the x-axis. So I'm going to take this first point and I'm going to mark it right here. And again, you'll see that my x values are staying the same, but my y values are changing. So again, I'm counting how far away from the x-axis it is, and I'm just going across on the other side. 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to run out of room on this one, but it would be probably about there. Okay? And just so that you can see the points, I'm not going to spend too much time trying to graph this line because, as we know, I'm terrible at it. Okay, and there's the reflection over the x-axis. Okay, now let's go ahead and record these points. Go ahead and write down the points over here. And now that we have all of our points in, we can quickly compare and our points and our reflected points. So our original point was -1, 1/2, and it reflected to -1, -1/2. That's a negative right there. So, and then 0, 1 reflected to 0, -1, 1, 2 reflected to 1, -2, and what do you notice? Hopefully you're noticing that the only thing that's changing is our y value, just like it did with our linear equation. So our coordinate notation went from x, y to the x value stays the same, but the y value becomes the opposite. So an example would be 0.38 reflects and becomes 3, -8. See that? Okay, and the only other thing left to do is to take a look at our equation and see how our equation has changed. So we had f of x equals 2 to the x power, and basically what we've done is we've said whenever we put x in, we're basically taking the opposite. The y value becomes the opposite. So that translates to a negative f of x, or f of x equals a negative, or negative f of x equals a negative 2 to the x power. So the only thing that's changed is that the entire y value is the opposite. So whatever the y value is the 2 to the x, because we put x in for the variable. We plug in our x, we do the work, we get the y value. So now we're just taking the negative of it. Now let's see if the same is true for flipping over the y-axis. So let's change my color and let's go ahead and take our same points and flip them over the y-axis. So this point right here would flip over to here, and this point right here would flip over to here. This one right here that I forgot about stays in the middle. This one, 1, 2, 1, 2. And this one, 1, 2, 3, 1, 2, 3. See it? And you can see that it's just kind of flipping over. It's like we took this paper and folded it along the axis, right? And we get a mirror image. All right. Now, let's take a minute and record all of these points. So we can record the exact same points that we had for 2 of x over here where it says f of x. And then we're going to record the opposite points, or the reflected points, over underneath f of negative x. So let's do that. Okay, I've gotten them all written in, and you can see that negative 1, 1/2 was my original point here, and my reflected point is right here, and it's written as 1, 1/2. And that my original point was 0, 1 here, and my reflected point is 0, 1 there. Then I have my third point was 1, 2, and my reflected point over the y-axis is negative 1, 2. And 2, 4 became negative 2, 4, and 3, 8 became negative 3, 8. What do you notice about these reflections? What happens to the points? Well, let's go ahead and write it. We've got xy translates to what? It translates to negative xy, right? Because the only thing that changed was the x value. And let's pick a point and see if that actually happens. Let's look at 2, 4. 2, 4, the x and the y translated to the opposite of the x, which would be negative 2, but the y stayed the same, which would be 4, negative 2, 4. And the last thing we want to do is we want to write our equations. And we started with f of x, which was 2 to the x power. And this is the part that changes here. The only thing that's really changing is the value of the x. So we write it as f of negative x. Not the negative f of x, but the f of negative x. So that means that wherever there's an x, we put a negative value. So it'd be 2 to the negative x power. Okay? Or 1 over 2 to the x power. Either one of those works, but it's the 2 to the negative x is really what we're doing. Okay? Now let's go ahead and do a little quick remember. Reflections, these are some important things for you to remember. Reflections over the x-axis change the y values. xy becomes x negative y. And the entire function is multiplied by negative 1. We take the opposite of it, all right? Reflections over the y-axis change the x values, and xy becomes negative xy. And only the x is multiplied by negative 1. And that's how we do reflections. Now it's time for you to write a key idea. And remember, a key idea is something that you want to remember. What is going to help you remember? Write the actual thing. Don't write, I have to reflect over the x-axis. Explain what happens when you reflect over the x-axis. The key idea is something that you should be able to read it and know exactly what this lesson was about. All right? And that's all I have for today. So I'll see you in class.